Now let's see the relation between irreflexive relations and symmetric relations. Okay, so again I don't know the diagram whether it is right or wrong, but I'll try to justify it, otherwise I'll change it. So let's say this is the anti-symmetric relations and it is irreflexive relations. Okay, and the outer rectangle is set of all relations possible as usual, and again we are talking about all the relations possible on a set with n elements. Okay, now A is set of all anti-symmetric relations and I is set of all irreflexive relations. Now what are the things that we already know? Let's call it as U, the set of all relations possible. So the things that we already know is cardinality of U is 2 power n square. This one we already know. Now what about cardinality of A? So number of anti-symmetric relations, this one also we already know. Anti-symmetric relations is 2 power n into 3 power n into n minus 1 by 2. This one we already know. And what about irreflexive relations? So irreflexive relations is n of, let us say, I. So there should not be any diagonal element, right? And in the remaining elements we don't have any restrictions, therefore it is going to be 2 power n into n minus 1. This is the number of irreflexive relations, right? Now let's try to justify all the regions, region 1, region 2, region 3 and region 4. So will there is region 1 existing, which means can you find out at least one relation which is anti-symmetric but not irreflexive? Yes. So let me call it as R1. If I have a relation like this 1 comma 1, this is definitely anti-symmetric, right? But it is not irreflexive. Why is it not irreflexive? Because diagonal element is present. So whenever you have a diagonal element, it is not going to be irreflexive. Got it? Therefore region 1 exists. What about region 2? So will region 2 really exist? Which means will there be any relation which is both anti-symmetric as well as irreflexive? So we should not have any diagonal elements if it has to be irreflexive, and we should not have any symmetric element pairs if it has to be anti-symmetric. Which means if I have 1 comma 2, there are no diagonal elements in this, isn't it? As well as there are no okay, what about empty set? I think empty set will also satisfy this R2, right? Which means if a relation, that is a relation which is both anti-symmetric and irreflexive. Empty set will not have both diagonal elements as well as symmetric element pairs. So or even 1 comma 2 is also an example. It is irreflexive because it does not contain any diagonal elements and it is not containing any symmetric pair, which means 1 comma 2, 2 comma 2, like that, 2 comma 1 type. So therefore it is definitely region 2 exists. Now what about region 3? I want to find out the relations which are irreflexive but not anti-symmetric. So what are the regions which are, what are the relations which are irreflexive but not anti-symmetric? So it has to be reflexive but not anti-symmetric. I can write a transitive pair here, symmetric pair here, 1 comma 2 and 2 comma 1. It is definitely irreflexive because it does not contain any diagonal elements, and it is not anti-symmetric because it has symmetric pair 1 comma 2 and 2 comma 1. Now let's try to find out relations which are neither anti-symmetric nor irreflexive. So region 4. If a relation has to fail in both the cases, it should have at least one diagonal element, then it is not going to be irreflexive. Then it should have one symmetric pair at least, then it is not going to be anti-symmetric. Yes, all the 4 regions are valid. Now in order to answer all the questions about the cardinality of various regions, you are supposed to find out region 2, which means number of relations which are both anti-symmetric as well as irreflexive. If we can find it out, we are done. We can find all the regions. Now how to find out the regions? This region 2. For that, let's talk about total number of ordered pairs possible, A cross A. It is going to have all the diagonal elements and then the non-diagonal elements of this type, right? Now out of all these elements, all the diagonal elements and non-diagonal elements, how can you find out the relations which are irreflexive? So we are not supposed to include this at all. Therefore the choice we have is don't include it. We don't have two choices, we have only one choice. What is it? Don't include it. So from all these diagonal elements we are going to get only one choice, and from the remaining elements, right, whatever you do with the remaining elements, you include them or don't include them, it is going to be reflexive. Therefore when you are going for the remaining elements, we have to test only about anti-symmetric, right? Therefore pair them up, and from each pair we are going to have three choices, either include the first element or second element or third element. Therefore each pair is going to have three choices. Like that, how many pairs we have? We have n into n minus 1 by 2 pairs. So the number of relations which are both anti-symmetric and irreflexive is going to be 3 power n into n minus 1 by 2, right? So it is going to be 3 power n into n minus 1 by 2. Got it? Now from this we can find the remaining areas. So what are the number of relations which are anti-symmetric but not irreflexive, which means n of a minus I. We can find it out easily, right? So what is it? N of a minus n of a intersection I. And we can find out what are the relations, how many relations are there which are irreflexive but not anti-symmetric. It is nothing but n of I minus n of a intersection I. Or we can find out the relations which are either a or I, which means which are either anti-symmetric or irreflexive. So a union I is going to be n of a plus n of I minus n of a intersection I. Or what are the number of relations which are neither anti-symmetric nor irreflexive? So which means n of a union I complement, which is going to be n of u minus n of a union I. So we have already got these four numbers. Using this we can solve any question on that. Okay, so in fact these numbers are exactly similar to the relation between reflexive and anti-symmetric, if you remember. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.